What actually goes into an AI agent? Six things. A trigger that starts it, a model that reasons, tools it can call, context it can ground on, deployment surface so something can invoke it, and observability so you can see what it did and what it cost. If you miss any one of those and you don't have an agent in production, you have a demo. Here's each one built end to end on a real agent. So, what is an AI agent precisely? It is a system that interprets an input, reasons about it, calls tools to gather information or take action, and works toward a goal, as opposed to a single prompt that returns text and stops. The distinction is a tool calling loop. A chatbot prompt produces one response. An agent decides what it needs, fetches it, evaluates what came back, and decides again until it reaches an outcome or hits a stopping condition. That loop is why agents need the other five ingredients. A prompt needs a model. An agent needs a model plus permissions, data, and a way to be held accountable for what it did. We're saying before we build one, a lot of automation shouldn't use an agent at all. If the logic is when this happens, do that, no judgment involved, route a form submission, sync a record, send a scheduled report, then you want deterministic automation. Same inputs, same outputs every time, no model, no token cost, no non-determinism to debug. The same platforms build both. In SIM, a workflow with no agent block is exactly that. Add reasoning only where the decision genuinely requires it. The agent we're about to build needs one because classifying an arbitrary support ticket requires judgment. Here's the agent we're building, a support ticket triage agent. When a ticket arrives, it reads the ticket, checks the help documentation for a known answer, assigns a priority, logs the ticket, and either posts to Slack or escalates for human approval. That's 5 decisions and 4 systems, small enough to build in one sitting, complete enough to exercise every part of a real agent. Step 1, set the trigger. The trigger is what starts a run. In SIM, a workflow can be triggered manually by an API call, by a chat message, by a webhook, by a provider event, or on a schedule. For ticket triage, the trigger is a webhook. The help desk posts the ticket to a URL the moment it's created. The choice matters more than it looks. A schedule means batch processing and a delay. A webhook means the agent runs per ticket in near real time, and your cost scales with ticket volume rather than with polling frequency. Step 2, add the reasoning block. The agent block is where model reasoning happens. It takes 3 things: instructions, a model, and a set of tools it's permitted to call. Instructions are the system prompt. Be specific about the output you expect. For triage, that's a category, a priority level, and a one-line summary. Vague instructions are the single most common reason agents behave inconsistently. For the model, SIM supports more than 100 across OpenAI, Google xAI, Grok, Cerebras, DeepSeek, and Mistral. You can use hosted access, bring your own API key, or run a local model through Ollama or VLM. Use a fast, cheap model for classification like this. Reserve a frontier model for steps that need real reasoning depth. Step 3, give the agent context. An agent with no context is guessing, and there are 2 ways to ground it. A knowledge base is retrieval augmented generation, documents chunked, embedded, and searched at runtime, so the agent retrieves relevant passages instead of relying on what the model memorized. SIM's knowledge bases connect to Google Drive, Notion, Slack, GitHub, and Gmail. For triage, point 1 at the help documentation so the agent can tell a known issue from a new one. A table is structured data the agent reads and writes. For triage, a table holds the ticket log. Every ticket, its category, its priority, its resolution status. So knowledge bases are for unstructured text you retrieve. Tables are for structured records you query and update. Step 4, give it tools. Tools are what turn reasoning into action. In SIM, that's integration blocks. 266 first-party blocks, exposing roughly 3,900 tool actions across more than 1,000 integrations. SIM is also an MCP client, so any MCP-compatible tool can be attached to an agent block. For this agent, the tool is Slack. Post the triage ticket to the right channel with its category and priority. Only grant tools the agent actually needs. Every tool you attach is an action it can take without asking. Step 5, add branching and a human check. Not every pass should be automatic. A condition or router block branches on the agent's output. For triage, low and medium priority tickets post to Slack and the run ends. High priority tickets take a different path. On that path, add a human in the loop approval step. The agent proposes the escalation. A person confirms it before anything is sent to an on-call engineer. SIM also supports guardrails and evaluators, checks that constrain or score agent output before it's acted on. Here's the rule worth internalizing. Automate the decision. Gate the consequence. Anything irreversible or externally visible deserves a human check until you've watched it behave for a while. Step 6, deploy it. Building it isn't shipping it. Deploying in SIM publishes a version snapshot of the workflow, so what's live doesn't change when you keep editing. Snapshot is exposed 3 ways, and you pick the surface. As a REST API endpoint, where you post a ticket payload to a URL and get structured JSON back, which is what the help desk webhook calls. As a hosted chat experience or embed, if humans should talk to it directly, or as an MCP tool or server so an external AI system can call your agent as one of its own tools. Same workflow, 3 surfaces, no rebuild. For ticket triage, the API endpoint is the one you want. Step 7, look at what it actually did. This is the step people skip, and it's where agents get fixed. Every run in SIEM produces a block-level execution trace. The inputs to each block, its outputs, any errors, how long it took, tokens used, and real dollar cost. Dollar cost per block matters specifically because agentic spend is non-deterministic. You cannot read the graph and predict it. A ticket that triggers 4 retrieval calls costs several times one that resolves immediately. The trace is how you find out that one branch is quietly expensive. Run 10 real tickets before you trust it and read every trace. That's where you find the instruction that was ambiguous. Now, 3 ways to build the same thing. SIEM gives you 3 build surfaces, and they're for different situations. Mothership is a natural language control plane. You describe what you want, and it builds, edits, and connects workspace resources. The workflow, the blocks, the connections. Use it for the first draft and for structural edits, because describing a 5-block change is faster than clicking it. The visual canvas is the block-based editor. Use it when you need to see the whole graph, tune one block precisely, or debug a branch. Explicit and inspectable. APIs and SDKs are for code. Use them when workflows need to be generated programmatically, live in version control, or ship through your existing CI. Most people use all 3. Mothership to draft, Canvas to refine, API to integrate. So what does it cost to build an AI agent? In SIEM, credits. 1 credit is half a cent. The free plan is $0 forever, with 1,000 monthly credits and 1 workspace, and is fully functional rather than feature limited. Pro is $25 per user per month, with 6,000 credits plus a 50-day refresh. Max is $100 per user per month, with 25,000 credits plus a 200-day refresh. Enterprise is custom, and SIEM is Apache 2.0 licensed and self-hostable via Docker, Kubernetes, or NPX SIEM Studio, in which case you're paying for infrastructure and model calls rather than a subscription. So, the checklist, regardless of what you build on, every AI agent in production needs 6 things. A trigger, what starts it, whether that's a webhook, a schedule, an API call, or a person. Reasoning, a model with specific instructions about what it should produce. Tools, the actions it's permitted to take, scoped to only what the job requires. Context, grounding in real data through retrieval over documents, structured records, or both. A deployment surface, an API, a chat interface, or an MCP tool, so something can actually invoke it. And observability, per run traces showing inputs, outputs, errors, latency, tokens, and costs. If you can't name all 6 for an agent you've built, the missing one is where it will fail. SIEM is Apache 2.0 licensed and self-hostable. Links are in the description.